things, important things. First, you know that human anatomy and physiology is to understand the human body, the structure and function of the human body. So it is a complicated field. Okay, it is not a very easy subject. So you must be serious from day one. Okay, a lot of things you will hear for the first time, new stuff. So you must repeat again and again to memorize it. Okay, so just keep that in mind that you have to spend a significant amount of time outside of the classroom. Okay. Uh, Another thing is uh, don't miss any class, lecture, or lab. Okay, if you miss a lecture or a lab, you'll see you are falling behind. Okay, it is very important that you don't miss any class. A lot of things during my lecture I will mention from outside. Probably you won't find those in the textbook, right? So if you miss, then you won't know that. And in the exam, probably you will have problem. Um, you must know how to use Blackboard because Blackboard is the platform that we use to communicate with the students. I do. So I'll quickly show you, okay, how to uh, log in Blackboard and where to find the stuffs, your learning materials. So, you know, this is your college web page, and if you see top right corner, MySQL, you will click there, and in the right side, you see a list of things. This is the Blackboard, which is the most important thing for you. So, you will log in Blackboard. Okay, so after you log in Blackboard, um, to log in, you will need your ID and password. You have to create a password. If any of you don't have it, make sure by today you get your ID and password. Okay. So if you don't know how, you can talk to the office downstairs in the first floor. Um, our campus is nice in a way that it's scenic as well as we have everything in one building, so it's very convenient, right? You can easily find someone. So in the first floor, inside the library, um, you can talk to them and they will help you to log in, okay, to get your password and ID. Your ID is the first part of your email. Anyway, so after you log in, you will go to this page and where you will find the list of the classes you have signed up. Here you see is the list of the classes I am teaching. So this is from instructor side, but your thing should be very similar. You will be able to see the list of the classes you have registered for this semester. Okay. Your section is this one, Bio 207 303. Okay. So if you click on that one, you see in the left side a number of things. A couple of things are very important. Announcements. Time to time, I will make announcements, so you will be able to see that. Another is course content. and lab materials. Course content is the location where you will find the syllabus, lab and lecture schedules, and also the PowerPoint slides that I post before the lecture. So you see I have already posted one PowerPoint file here. Okay. Um, I would recommend you to print out the instructions, lab and lecture schedules. So print this information and put in a folder. In that way, everything will be in one place, right? So you won't come to me. When is my next exam? Sometimes students can easily check here. You don't need to come to me, right? Of course, you can come to me, but that's not the efficient way. You will walk around to find me and ask me a question that you can, get in one few seconds if everything is in your folder. So print this information, or nowadays you are more, used to use the computer, iPad or iPhone, but make sure that you have this information ready whenever you want to see, you can see it. Make sense? Okay. Um, so if I'll quickly go over these three things. So here you see my name, uh, then your class hours. You have 2 lectures in a week and 1 lab. Okay, so Tuesday, Thursday. My contact information, my phone number, email address, and this is my office in the second floor of this building, room 228. Feel free to email me, call me, or come to my office. Okay, if you have any issue. This is your textbook, Human Anatomy and Physiology by Mariam. This textbook you will use both for your ANP1 and 2 if you take your ANP2 here. Okay? If you go to another campus, they use different book. For example, Forest Park, they use Martini. Pleasant Valley, they use a different book. 10th edition is the latest one, but if any of you have 9, that's also acceptable, but not before that. So 9th or 10th is fine. Lab manual from last semester, what I have done, I have created the lab materials, so you don't have to buy the lab manual. That's good news for you. Okay, it was expensive book. So I will post the lab materials before the lab. So you will print it out and bring it. Make sure you print out and bring, okay, in the lab. So you don't have to buy the lab manual, but textbook you must have. Okay, then just you all read the information here. What are the topics we'll cover in NP1? Briefly listed here, so I am not going to read, but make sure you read this information. Exams, very important. There are 5 lecture exams and 3 lab exams. Each exam has 100 points. So 5 lecture exam altogether have 500 points, and 3 lab exams 300 points. So out of 800, your average score will be calculated and will grade based on your average score. So if, for example, out of 800 your score is 500, then very simple math. This is your percent average. Okay, so If you get 90 to 100, your letter grade will be A. If you get 80 to 89, will be B. 70 to 79, your grade will be D. Okay, I don't want to go further down. Okay, I hope you will stay within top 2 or 3. Uh, Now the question is how. As I have already mentioned, that you have to spend time. There is no alternative of that. Spending a good amount of time. Okay, keep that in mind. Uh, in anatomy and physiology, a lot of things, as I have mentioned, you have to understand as well as memorize. So both are important. And how to memorize the things. You will see the thing, you will listen as well as you will touch. That is also very important, particularly in the lab. When you will do the lab, make sure you see, you listen, and also at the same time you touch it. Like when you will study a bone, this is the humerus. So you will tell somebody, okay, to the next person, this is humerus. Although you know it, this is humerus. And your partner will also tell you, this is humerus, okay? And this is the head of the humerus. When you say that, every time your hand should go there and touch it, that information will go to your brain, okay, and will be stored there. So it is very important that in anatomy, that anesthetic sensation and as well as the audition and vision all are important. Okay, so use all methods together. I'm here to help you. Okay, to pull you up. But I tell always to my students that I'm here to help you. But if you don't extend your hands towards me, then I cannot help you, right? You have to know how to get the help. Like I teach more than 100 students every semester. This semester you have seen I am teaching 6 sections. So I cannot keep information of all the students who is doing good or bad, everything, right? So you should come to me, okay? If you have any problem, you should come to me and talk to me. That's the right way. Okay, I cannot go to 100 students and ask. I'll try, but that's not the efficient way. So feel free to come to me anytime. You can come to me. Okay, talk to me. Uh, okay, so let me see. Another thing is that inside the classroom, we must follow some rules. You know that when you drive on the street, you follow some rules, right? Everywhere there are rules. So you are mature enough, I believe, and you know how to behave inside the classroom. So don't disrupt, don't disturb others. Okay? During lecture, if your cell phone suddenly rings loud, and it can happen accidentally, but you should not, you should be careful. Keep the cell phone in silent mode. I understand it is important. Sometimes you may get important calls. So in that case, feel free to leave the room, finish your conversation and come back. Okay. But don't disturb. Keep that in mind that your behavior doesn't disrupt others. Okay. Or disrupt the whole classroom environment. Just I'm mentioning in general, that's the thing you have to keep in your head. Okay, so do you have any questions? No question. So everything is clear. No question could be two meanings. One is you didn't understand anything, or you understood everything. Okay, whatever. So if you don't have any question, I'll move forward. Also, the lab schedule you see here. There are 3 lab exams, exam 1, 2 and 3, and 5 lecture exams. So everything is listed. You just keep these printouts in your folder. Another thing, this is just my suggestion. I have seen that the students make a folder, nice folder for like Anatomy and Physiology 1 or NP1 and put everything in a folder. That's a very good way, to go, because you can carry the folder everywhere. If you get 10 minutes somewhere, you are waiting to fix your car, you can sit and just go over. Okay, that is very helpful if you make a binder or folder. Okay, so print out of the PowerPoint slides, put in the binder. Exam questions. Most of the questions in your exam will be multiple choice. There will be few short questions, but most of them will be multiple choice, and most of the questions will be from the PowerPoint slides that I post and my lecture. During the lecture, you'll take the lecture note, right? Those 2 things. Remember, those 2 things are very important. PowerPoint slides and my lecture in class. Then beyond that, when you'll get a chance, read the textbook. Definitely you will read the textbook. So first 2 things are PowerPoint slides and the lecture note you take during the class. If you can take good lecture note, you should not have any problem. Most of the questions will be from those 2 things. Okay, so I'm going to start today's lecture. Yes. If you want to record, make sure that it is solely for your own purpose. Okay, you are talking about recording the lecture, right? Yeah. So after you are done this course, you remove everything and keep it safe in safe place and don't share with others. Okay, so that's the condition. Okay, so this chapter is the orientation of the human body. In this part of lecture, first we'll see how to define anatomy and physiology. Since this is an anatomy and physiology class, you need to know how to define anatomy and physiology. Then we'll see the branches, important branches of anatomy and physiology. Then we'll talk about different levels of organization of the human body. Human body is very systematically organized from the largest to the smallest. Okay, so we'll see what are the different levels of organization of the body. Then we'll talk about the systems in the human body. A human body consists of 11 systems. For example, cardiovascular system, nervous system, urinary system, respiratory system, right? So 11 systems joined together to form the whole body. So in this part, we will go over those 11 systems one by one. Okay, and just we'll get some idea about those systems in our body. Then we'll talk about the necessary life functions and survival needs, those couple of things. First, what is anatomy? Anatomy is the branch of medical science that deals with the structure of the body. So anatomy deals with the structure. We can also add structure and form. Okay, structure and form of the body. Now, there are few branches or divisions of anatomy. One important branch is called the gross anatomy or macroscopic anatomy. The word macro means large, big. So gross or macroscopic anatomy is the study of large structures. And to study the large structures, you don't need microscope. You know that, right? If I show you a heart, by looking the shape and size, right, you can tell this is a heart. Do you need microscope? You don't need, right? So this is gross or macroscopic anatomy. Another branch is the microscopic anatomy. Micro means tiny, very small. So study of the structure and form of very small structures. For example, if you want to study a cell, cell is very small, microscopic. So to study a cell or tissue, you need to see them under the microscope. You need to use the microscope. You need the help of the microscope. So that is the microscopic anatomy. Now microscopic anatomy has two divisions, cytology and histology. Cytology is the study of cell and histology is the study of tissue. Cyto means cell and histo means tissue. Okay? And to study a cell or a tissue, you need the microscope. So these are the branches of microscopic anatomy. Now, another important branch is the developmental anatomy. You know that the body grows first inside the mother's body, inside the uterus, then after the birth, body continues to grow, right? And your all body parts simultaneously grow. So, if you study the change of the body structures during the growth of the body, that is the developmental anatomy. How a heart is being formed, right? How kidneys are being formed. If you study at different stages of development, that is the developmental anatomy. One important branch of developmental anatomy is the embryology. You know embryology, first 8 weeks of life in mother's uterus. That is a branch of developmental anatomy. There are a couple other branches of anatomy. One is called surface anatomy. Surface anatomy is the study of a structure by looking the outside landmarks of your body, outside markings of your body if you want to study any structure. Let me give you an example so you will clearly understand. We know that the heart is located inside the thorax, right? Heart is located inside the thorax and in right or left side mostly. Left, we know that, right? Now, we also know that heart is located in between second and fifth intercostal space. Second intercostal means in between the ribs, and you know that you can feel the ribs from outside, right? You can feel the ribs. So the surgeons, when they will do the surgery, what they will do, they will feel the ribs. This is first rib, this is second rib. So this is the second intercostal space, and then this is the fifth intercostal space. So they will draw a line that your heart is located there. Okay? Then they will make the incision and open. So that is the surface anatomy, which is used in surgery a lot. Neurosurgeons use the surface anatomy all the time because we have sutures, right? You know, on the skull. So they know from this suture, if they go 10 millimeter or 20 millimeter, what structure they will be able to get. Make sense? So that is the surface anatomy, which is used by the surgeons a lot to locate the structure. Another branch of anatomy that is called, we have talked about surface anatomy, systemic. Systemic anatomy is the study of a particular system. If an anatomist decides that I'll only study the structure and form of cardiovascular system, I don't care other system. Make sense? So that is systemic anatomy. If you only study the nervous system, that is the systemic anatomy. And there is another branch that is called regional anatomy. If you study a particular area, structures in a particular area, for example, there is a branch that is called head and neck anatomy. You'll see the book, head and neck anatomy. That means that anatomy only study the structure of that particular part of the body, area of the body. Make sense? Region of the body. So that is the regional anatomy. So these are the branches or divisions of anatomy. Physiology. Physiology is the science that deals with the functions. So anatomy deals with the structure and form, physiology deals with the functions. Now, there is a important thing here. What kind of function? Physiology deals with the normal function, not abnormal function. So physiology deals with the normal function of the body. Now, the science that deals with the abnormal functions of the body, that is called pathology. So pathology deals with the abnormal functions. Physiology deals with what? Normal. So physiology deals with normal function, but pathology deals with abnormal function. Okay. So if you take the pulse of a person in resting condition and you see the pulse is 70, is it normal or abnormal? Heart rate is 70. Normal or abnormal? Yeah, resting condition, adult person. Is it normal or abnormal? Normal, right? We know 70 to 80 definitely normal. If you don't know, you should not study NP1. Okay. So that is normal, right? So that is physiology. Now, if you see a person, adult person sitting in normal resting condition and the pulse is 150, Is that normal? That's not normal, right? That is tachycardia, arrhythmia. So that is pathology. That is no more physiology. Make sense? So that is the difference. Now, anatomy and physiology are inseparable. This is a very powerful statement. Anatomy and physiology are inseparable. Why? Because all body structures are designed to perform specific functions. For example, your heart is structured. That means the anatomy of your heart is to do what? Pump the blood, right? Your joints are designed to help in the movement. Make sense? So you see that structures are designed to perform specific functions. That means anatomy and physiology. Anatomy is to execute the physiology or perform the function. Okay. Now I'll just write down the branches of physiology. It is not on the slide. Physiology has a couple of important branches. Just write down the name. One is systemic physiology, same as systemic anatomy. If you want to study the functions of only one system, cardiovascular system or nervous system, it's systemic physiology. Another important branch is comparative physiology. Comparative physiology studies or compares the function of organs in between the species. Compares the functions in between the species. For example, if you study the function of the heart of a human and a dog or a sheep, then you put side by side. This is how the human heart works. This is how the sheep heart works. Okay, so you put side by side. That is the comparative physiology. Another important division is neurophysiology. Okay, so neurophysiology is the division of physiology that studies the functions of the nervous system. Okay, so those are important divisions of physiology. Different levels of organization of the body. You remember I mentioned at the beginning that human body is highly organized from the highest to the lowest levels. So if you see from the lowest, that means the smallest, to the highest, that means the largest levels of organization, how the human body is organized from the smallest to the largest. The smallest level is called the chemical level that deals with atoms and molecules. So atoms and molecules belong to the chemical level. Then one step higher level is the cellular. Cells and the organelles of the cell. You know that inside the cell you have mitochondria, endoplasmic reticulum, ribosomes, right? Those are the organelles inside the cells. So cells and the organelles belong to the cellular level. Then if you go one step higher is the tissue level. Many similar cells combine together to form a tissue. Then one step higher is the organ. two or more different types of tissues join together to form an organ. Two or more tissues join to form an organ. For example, can you give me an example of an organ in your body? Heart, right? Organ transplant we use all the time. Your heart, lung, kidneys, those are the organs, right? Blood vessels. So if you see the heart, for example, this is the heart. This is the wall of the heart. And if you see the structure of the heart, you'll see there is a outer covering, that is the connective tissue, and then middle layer is the muscle layer, cardiac muscle, and inner thin layer is the epithelial tissue. The connective tissue, muscular tissue, epithelial tissue. You see, heart is formed by those three different types of tissues. Similarly, blood vessel. If you see an artery, which is an organ, outer is the connective tissue, middle is the muscle, inner is the epithelium. So three different types of tissues joined together to form the organ. Okay. In this case, there could be more than three. Then different organs join together to form a system. For example, cardiovascular system is a system, right? Cardiovascular system is a system in your body. It has what? Which organs? Lungs are respiratory. Lungs are part of respiratory system, right? So cardio means what? Heart. And vascular, blood vessels, right? So heart and the blood vessels. What are the blood vessels? Arteries, veins, capillaries, right? So those are the organs in your cardiovascular system. Heart, artery, veins, capillaries. Make sense? Respiratory system. Nose, right? Trachea, larynx, your lungs. Those are the organs. So they join together to perform the function. And that is the system. Okay? So organs join to form a system. Work together to form a system. In human body, we have 11 systems. How many? 11 systems. And 11 systems join together to form the whole body, and that is the organism. Organism is the whole body. Okay? So those are the different levels of organization. And what kind of questions I may ask? Just think about this slide. I can ask you, tell me in right order, sequence from the lowest, that means smallest, to the highest levels of organization. You have to remember that. If I ask you what is a tissue? Tissue is the collection of similar cells, many similar cells, right? Different organs join to form what? System. How many systems you have in human body? 11 systems. So those are the type of questions you can easily think. What could be the questions from this slide? Here, they have shown those different levels. So if you see top left, atoms and molecules belong to chemical level, cells and organelles belong to cellular level. Then you see here they have shown many smooth muscle cells have joined to form the smooth muscle tissue. Okay, so similar cells, many similar cells. Then they have shown the organ. This is a blood vessel, as I have shown you. Outer connective, middle muscle, and inner epithelial tissue. So organ is formed by different tissues. Then you see the system level. They have shown the cardiovascular system, and the organism is the whole body. Okay. Now, as you know that we have 11 systems in our body. So what I'll do in next few slides, I'll go over those 11 systems one by one. Briefly, two things I will mention, and you have to remember. One is important organs of each of those 11 systems and important functions. Just a couple of important functions from each. Okay. Then in rest part in future we'll go into detail of those systems, but for today just a couple of things: important parts or organs and important functions. So first, the integumentary system. Integumentary system consists of the skin, which is the main organ of this system, and other structures are hair, nails, and the glands of the skin. Remember, glands of the skin, not all the glands of the body. Okay, now functions of the integumentary system. Integumentary system covers the whole body. You know that your skin covers the whole body, right? And by covering the body, integumentary system protects your internal organs from outside harms. Just simple example, because of your skin covering, microorganisms cannot easily enter into the body, right? You know that. Everywhere, although we don't see, microorganisms are flying, right? In the water, you have a lot of microorganisms, but they cannot easily get into the body because of the skin covering, right? If something hot, very hot, touches your body, first the skin will take that heat, okay, to protect the internal organs. So protection. Another important function is the synthesis of vitamin D. How skin helps in the synthesis of vitamin D? When the sunlight falls on the skin, your skin produces a chemical with the help of the sunlight. That chemical is called cholecalciferol. Let me write it down here. Okay. Skin produces cholecalciferol with the help of what? Sunlight, right? And cholecalciferol is an precursor of vitamin D. That means inactive form of vitamin D, cholecalciferol, and your skin produces it. Then the cholecalciferol goes to the kidneys, and inside the kidneys, cholecalciferol is converted to calcitrol. I don't know if you can see from there. Cholecalciferol is converted to what? Calcitrol. Where? Inside the kidneys. And calcitrol is the active form of vitamin D. Okay, active vitamin D. So you see that your skin helps in the synthesis of vitamin D. Make sense? That is another important function. Now you can ask me why in the kidney? Why it has to go to the kidney? Why not in the liver or spleen or pancreas? How will you answer? Why is that? Why it has to go to the kidney to get converted to active form, to become active? Because kidney has that chemical that will convert it to from inactive to active. That's simple. Kidney produces that chemical that is called converting enzyme, CE. So converting enzyme is produced in the kidney, not in other organs. That's why it has to go to the kidney. Okay. Another very important function is housing the cutaneous receptors. The word, remember, cutaneous means skin. Cutaneous means what? Skin. We use all the time cutaneous sensation. That means sensation in the skin. So cutaneous receptors. What are the cutaneous receptors? Pain receptors, touch receptors, temperature receptors. Those are the cutaneous receptors present in your skin. Pain, touch, temperature. And that's why you feel those sensations in the skin. And that sensation are very important for your survival. Just think simply. If in this room the temperature goes up, your skin will detect it because your skin has what? The receptors, temperature receptors. It can detect heat and cold. Make sense? So you will quickly get out. I can't stay here. If you don't feel then, what will happen? Your organs will fail in high temperature. So that is one example. Another is if something hot touches your skin, you immediately feel it and move away, right? If you don't feel that, you won't take the action, right? You will not move away. So for our survival, we need the cutaneous receptors. Okay. So those are the important functions of the integumentary system. Then next is the skeletal system. Skeletal system is the skeleton. So very simple. That is the skeletal system standing there. You see, that whole thing is the skeletal system. So skeletal system consists of the bones and the joints. Functions. Number one is protection. Your skeletal system protects the important organs of your body. For example, your brain. You know that brain is the most important organ of the body, right? And your brain is heavily protected by what? The bones. Cranial bones, right? Skull bones. You see, your eyeballs are protected by the bones, right? Your tongue, your nose, everything. Your heart. You know that heart is located here. Heart is protected by what? The ribs. Very good. So, a skeleton provides protection. Number two, supporting. Just simple way, think that this skeleton, it supports the whole body, right? Skeleton supports the whole body. Now, if you think individual level, your eyeballs are supported by the bones, surrounding bones, right? Your brain is supported by the cranial bones. So support is another important function. Then provides attachment of the muscles. Your skeletal muscles get attached to the bones, and since the skeletal muscles are attached to the bones, skeletal muscles can move the bones. So providing attachment to the skeletal muscles is another important function. Another is blood cell formation. Inside the bones, you have red bone marrow. You know that, right? Red bone marrow is the primary site of blood cell production. All blood cells are mainly produced in the bone marrow, right? Blood cells, red blood cells, white blood cells, platelets are produced in the bone marrow, and bone marrow is located inside the bones. The last one is storage of minerals. Which minerals are heavily stored in the bones? calcium. You know that calcium is the main mineral in the bone. If someone, when we get old, our bones get weak, right? And you will see the doctors will give calcium, take calcium to make the bone strong, right? So calcium is the main mineral, also phosphate and magnesium. So just write down those three: calcium, phosphate and magnesium. Those are the important minerals stored in the bones. Muscular system. Muscular system consists of the skeletal muscles of your body. As I have already mentioned, that skeletal muscles are attached to the skeleton, right? To the bones. And skeletal muscles help in locomotion. That means the movement of the bones. Without the muscles, bones can't move, right? So, bones move at the joints with the help of the skeletal muscles. That's the statement. Bones move at where? At the joints with the help of the skeletal muscles. The skeletal muscles help in locomotion. Facial expressions. The expression of our face changes. In your face, you have several small, tiny muscles, facial muscles. And with the help of those facial muscles, we change the expression of our face. For example, when you get angry, your face changes, right? When you are sad after the exam, face changes. If you are happy after the exam, someone can tell you are happy. So those are the facial expressions given by the skeletal muscles of your face. Another important function, some facial muscles help in mastication, chewing the food. Right? We move the mandible with the help of the muscles. So those are the important functions. Another is the production of heat. If in very cold temperature you go outside without enough clothes, your body will start to shake, right? Why that happens? To protect you, because when shaking of the muscles, shivering occurs, the muscle activity increases, right? And heat is produced. So when muscle activity increases, when you do exercise, heat is produced, right? So increased muscle activity increases the production of heat. So that's how the body temperature is controlled.
What was that term you used for chewing?
The few facial muscles help to move the mandible, right? Jaw. And that by moving the jaw, you chew the food.
But you used a different term.
Mastication.
Oh, okay. Mastication. Yes. Mastication. Okay. Now, next is the nervous system. Nervous system is the most important and powerful system of our body. Why? Because two systems of your body control all body functions. One is called the nervous system and another is the endocrine system. Okay? Nervous and endocrine. Those two systems are controlling systems. They control the body functions. But remember that among those two, nervous system is more powerful. Why? Because nervous system is fast acting, acts very fast. So it is more powerful. So just think that you got your air conditioning system broken in your house, down, right? In summer. So you have called two guys. And one guy said, I will come day after tomorrow. And another guy will say, I I'm coming right now, and came and fixed your problem, right? Then another guy came after 2 days. So who is more active, right? So fast acting is more active, right? Coming quickly, fixing the problem. So nervous system is fast acting. Endocrine system works through hormones, so slow acting, but it is also powerful. Why nervous system acts quickly? Because the nervous system sends signal by electrical means, electrical signal transmission. Have you heard that? Electrical signal transmission. And you know that electrical signal transmission is what? Fast, right? Very fast. So, nervous system can quickly send signal to any part of your body and try to fix the problem. Okay? So, fast acting controlling system or control system of your body. Endocrine system consists of the endocrine glands. Now, endocrine glands work through hormones by producing and secreting hormones. And hormones then go to the target organs and perform the action. So you see here, endocrine system must produce the hormone, secrete the hormone, or release the hormone, and then hormone should be taken to the site of action by the blood. So who takes the hormone to the site of action? Who takes the hormone to the site of action? Blood. Blood will take the, who will produce? The endocrine glands, right? And will be secreted into the blood, and blood will take the hormone to the site of action. So here you see few steps. First, the glands do what? Produce hormones. Then release, right? Secrete into the blood. Then blood does what? Transports it to the site of action, right? So all those things have to be done, and it takes some time. That's why it is slow, much slower than the nervous system. Nervous system sends signal how? Electrically, right? Through the nerves. So nerve will quickly take the signal. Make sense? Quickly take the signal. That's why it is faster. But both are important.
They're both pretty fast, so I mean, so much scares you to get adrenaline that happens very fast.
Adrenaline should bind with the receptors. Also, in some cases, hormones work, neurotransmitters are hormones. In this case, neurotransmitter will work through the nerves. So they work together actually. The adrenaline will be released, then sympathetic nerves will be activated. Okay, and the activation of sympathetic nerve will release adrenaline and will activate the sympathetic system. So nerve and the chemicals will work together in this case. But in some cases, there is no connection with the nervous system. The thyroid hormone, right? Thyroid hormone will be released, will go to the blood, will work on the muscles. In this case, nerves are not related. Okay, so when the nerves are related, it will be faster. You are right. But in most of the cases, nerves are not related there. Okay, so in that case, it will be slower. Not only taken to the site of action, then after going to the site of action, just think that what happens. The hormones must bind with the receptor. Receptor hormone binding should occur, then the signal transduction will occur. So, although everything in microsecond, remember, or millisecond, but there is a big difference between millisecond and microsecond. But both are very fast to us. But if you really think physiology, millisecond and microsecond, like 1,000 times different, right? So that is the difference. Okay, so just I will show you important endocrine glands. in your head, in the brain, you have two important endocrine glands. Both start with P, pituitary and pineal. And just know that pituitary gland is called the master gland. Pituitary gland is called the master gland. Why it is called the master gland? Because it controls all other glands. Okay. So pituitary gland controls the other glands. Another gland in the brain is the pineal. Pineal gland performs a couple of important functions. I'll just mention two of those functions. One is circadian rhythm. Have you heard this word, circadian rhythm? Day-night cycle, sleep awakeness cycle. Sleep awakeness cycle. That is called circadian rhythm. So you know that sleep awakeness cycle in our body, right? That is controlled by the pineal gland. Another is the production of a chemical that is called melatonin. Synthesis or production. Okay, so these are two important functions of the pineal gland. Then, if you go down in front of the lower part of the neck, here, in front of the lower part of the neck, you have the thyroid gland, another important gland, you know, thyroid. Thyroid gland is mainly responsible for the metabolic activities. It controls the metabolic activities of the body. Another function of thyroid is it lowers the calcium in the blood. Calcium, it lowers the calcium. So regulation of calcium, you can also write regulation of calcium. So two important functions I have mentioned. One is it controls the metabolic activities. Number two, regulation of calcium. How? By lowering the calcium. Decreases the calcium in the blood. Okay, then go to the thorax. In the upper part of your thorax here, you have a gland that is called the thymus. Have you heard thymus? Yes or no? Thymus. Thymus, how many of you have heard the gland thymus? Show me the hands. Thymus. Okay, couple of you didn't. You should. You have taken intro bio, I believe, right? So you should know the thymus. I'm not asking you the functions of thymus. I'm asking you if you have heard the name of thymus. Okay, so thymus is located in the upper part of the thorax here, and just write it down that thymus is responsible for immunity, defensive functions. You know, in very early life, if you see the thymus of an infant baby, it is very big. It also actually occupies the whole upper part of the thorax like this, and gradually it shrinks, gets smaller. And in our adults, the thymus is like this. Okay, but in infants, it's very big. Why? Because in early life, the immunity is less, right? So it needs to work more. Anyway, so that is the thymus. Another thing, in the back of the thyroid, you know, thyroid is here, in the back of the thyroid, you have 4 to 8 tiny glands attached. So if you see the back of the thyroid gland, this is the thyroid gland, you have tiny 4 to 8 glands attached to the back of the thyroid gland, and these are parathyroid. Parathyroid glands. Okay. Parathyroid glands, how many? 4 to 8. It varies. And remember, parathyroid glands are very important because parathyroid hormones increase the calcium in the blood. So, elevates or increase the calcium in the blood. Calcium regulation. So, you see, thyroid hormone decreases, parathyroid hormone increases the calcium. And by the action of those two, your calcium is controlled. Cardiovascular system. Oh, I didn't mention a couple more glands here. So go down now. In your abdomen, you have a couple of important glands. One is the pancreas. Have you heard pancreas? Pancreas? No?
Yeah.
Okay. So pancreas produces two important hormones, insulin and glucagon. Have you heard insulin? Insulin? No? You must have heard.
That's why you're learning.
No, that's fine. Insulin, we all know because insulin is the treatment of what? Diabetes, right? You know that? Diabetic patients take insulin. If your body cannot produce insulin, then the blood sugar goes up, right? Okay. So, pancreas produces two hormones, insulin and glucagon. Glucagon. Okay. Insulin does what? You have to tell me. Reduces the sugar, right? We all know that. Insulin, who takes insulin? Diabetic patient.
Oh, I let you.
Okay. Oh, you take it. Okay. So, diabetic patients, right? To do what? To lower the sugar, blood sugar. So, insulin lowers the blood sugar. Just know that glucagon does opposite. So, glucagon does what? Raises the blood sugar. And by the action of these two, your blood sugar is controlled in normal range. Okay. Then, if you see on the top of the kidneys, you will see the adrenal glands. So you have two kidneys, therefore you have two adrenal glands. So if this is the kidney, on the top of the kidney, like a crown or cap on the kidney, you have the adrenal gland. And adrenal glands perform a number of very important functions. I'll just mention 3 or 4 of them. Adrenal glands are really very important glands. They perform a number of important functions. Number 1, adrenal glands regulate the metabolic activity. Number 2, adrenal glands regulate the minerals. So number 1, metabolism. Number 2, regulation of minerals. Number 3, strong anti-inflammatory action. Strong what? anti-inflammatory. It reduces the inflammation. Have you heard the name? If you get inflammation, you get the ointment like red eye, hydrocortisone. You heard that? Drop or ointment. You see, hydrocortisone is a adrenal hormone. It is an adrenal hormone, and that has a strong anti-inflammatory. You have seen when you put quickly the inflammation goes away, right? And that is only you will see 0.1, 0.2%. That strong. So if you give more high concentration, it will work very fast. So strong anti-inflammatory. Then another one, production of sex hormone. Production of sex hormones. We know that testes, ovaries produce sex hormones, but also adrenal gland produces sex hormones. Okay? And the last one, write it down, that production of adrenaline that you were mentioning, adrenaline. Have you heard adrenaline? Yeah, sometimes you will see on the DVD box. This movie will increase your adrenaline secretion, right? So that means what? It will, yeah, heartbeat fast, a lot of excitement, drama, right? Here. So that adrenaline activates the sympathetic system. We will talk about that later. Just know that production of adrenaline is another important function. So those are some important functions of your adrenal gland. Now, if you go further down, in male, you have male gonads, testes. In female, you have female gonads, ovaries. So, in male, the gonads are testes. In female, the gonads are ovaries. And the gonads are also the part of the reproductive system. So, gonads are part of endocrine as well as reproductive system. Because just think about testes. Testis does what? Produce sperm, right? That is the function of reproduction. And testis also produces hormones, testosterone, sex hormone. So that is a function of what? Endocrine, right? So gonads are parts of both endocrine and reproductive system. And production of sex hormone is the endocrine function of the gonads. So how many gonads the female body has? 2 ovaries, right? And in male, 2. Don't forget. In one exam, I wanted to give very easy question. Like fill in the blank. Male body has this many testes. I got a couple of answers like 1, 3, 5. Like that. Okay. So yeah, interesting. Okay, so let's stop here today.